Hello everyone, welcome to Micro Minutes. My name's Marty Jobson, and today, for the microscopy today, I wanted to show you a human biological specimen, which is why I've got this bigger microscope out, because it's got more power and it also allows me to do some clever stuff that makes invisible stuff visible. Because the specimen I'm going to show you is cheek cells, buccal cells they're called, scraped from the inside of my own cheek, and to do that I need this. This is sort of the longest cotton bud you've ever seen, and all I do is ha 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 ha, ah ha 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 ha, a bit of that. So I've got some cells from me on the end there, and now if I do this, what I have here on the table is a little glass slide, and I'm going to take the cells which are on here and I'm going to squidge them onto there. Now, cheek cells, like most cells in the body, are pretty much see-through. There's not really much there to see. Right, okay, I should have squidged everything on, which is why you need to use some special clever optics. Now, then what I'm going to do is I've got another piece of glass here. This is called a glass cover slip, and I'm just going to pop that on there like that and lower it on. Ooh, this is a bit tricksy, but there you go. Oh, I've done a good job of that. And then blot away the excess liquid very gently. And then what I'm going to do is I'm going to go back. I'm going to go back to this so that you can see me, and I'm going to put this under here and have a look, and just to make sure there's actually something to see there. Because oh blimey, yeah, woohoo! Yeah, I definitely scraped a few cells off there. I got a bit carried away. I'm going to zoom in a little bit so I can show you exactly what I want to see. Okay, this is good, this is good. And then I'm going to try and find a clump of cells. And I'm looking for something very specific on the surface of the cells as well, which I'm not finding, which is interesting. Let's have a look what we got over here. Okay, well let's go with this one here. And I might have to save that for another day, so to speak. So, okay, let's see. Is that coming up on my microscope? Yeah, let me set the exposure. So using this microscope, whilst this microscope has more sort of oomph to it, everything takes a little bit longer. It's a bit more complicated to use. So apologies if I pause, but here we go. This is what the cells that I literally just scraped off the inside of my mouth look like. So this is magnified quite a lot. I am now, this magnification here is, oh, I can't remember, is that is times 40, and there's times 10 up there, so that's 400 times magnification. And you're looking at something, these are maybe, 20, 30 micrometers across, so 20 or 30 thousandths of a millimetre. And if I use my little pointy thing here, what you're looking at is a clump of cells. Here's one cell, here's another cell, here's another one up here, and there's another one, and another one, and another one, and another one. And the reason I know these are different cells is because I can see the cell nucleus in each one. And that's the sort of, it's showing up bright here, dark here, bright here, dark here. And depending on how I focus, if I change the focus, you'll see it adjusts ever so slightly like that. You can see there, and that's the surface of the cells there. But I know those are the cell nucleus because experience, but also they're the one thing that shows up when you use this technique. Now, normally, if you look at these cells without special optical techniques, they're pretty much see-through. I can show you that if I just change a sort of a little setting that I've got down here underneath the stage of the microscope. And if I just put that like this back to just the ordinary setting, and then I have to change the exposure because, it's I might have to do, is it going to work? Is this going to work? Yeah. And you can see the cells, but not very well. They're just about there. Here, you can sort of see them. And if I fiddle with this, you can sort of, ooh, yeah, you can just about see the cells. And that's because the cells from the inside of your mouth are essentially see-through. Individually, it's when we put lots of cells together and blood and all the other bits of tissue that we become not see-through. but the light passes pretty much straight through these cells. I'm just going to set the white balance as well on that, so that it actually looks white as opposed to sort of weird pink. So the light pretty much goes straight through those cells, which is why you can't see them. But what I'm using is something called phase contrast microscopy. Shoink, shoink. And phase contrast microscopy, I have to change the exposure, but once it's working, boosts what we can see. And I'm not going to go into the details of how it works because it's really quite ferociously complicated. The physics of it is quite difficult. But essentially what it's doing is it's allowing us to see something that is pretty much invisible to the naked eye, which is kind of cool. And what you can see is you can see some of these cells that I've scraped off the inside. Now, the cells on the inside of your cheek, very rapidly dividing, they form layers, sheets and epithelia, which sloughs off constantly. You're constantly losing these cells and swallowing them down. And when you swallow them down, they just go into your stomach and that's the end of them. But they're sort of circular, but then because they're all squished together, you get these sort of flat edges where they join, like here and then here. And see, this one's got lots of sort of creases on it, this cell. And in the middle is a cell nucleus. And the wonderful thing about phase contrast, normally, if you do this at school, you stain the cells. And I've shown stained cells before with blood, but that kills the cells. Phase contrast doesn't kill the cells. These are cells that are still alive. Admittedly, they probably won't be alive for much longer because they're just in water. But they're alive, they're live cells. This is a living specimen, living bit of me that you're seeing. And inside that cell nucleus, there is DNA. And that DNA, that deoxyribonucleic acid, is what is coding for me. It's what makes a Marty Jobson. And you can see other stuff inside the cell, all these little bits here. And the nice thing is I can focus that I'm looking at the inside of the cell, like this. All these bits here are sort of bits of other, little bits of other things that are going on, things like ribosomes and endoplasmic reticulum and Golgi bodies and all sorts of weird things like that. But if you surface just on the surface, focus just on the very surface, sometimes, depending on how well I brush my teeth, you can see there's some there. There's two there. Can you see that? I'll zoom into that. It's just, where is it? It's just there. I'm going to zoom in on this. Can you see? So I'm doing, this is a digital zoom. I'm just expanding the picture. Can you see there's two tiny little blobbies there, okay? That look like two little sausages, two little chipolatas meets together. And those are bacteria. Probably either Streptococcus mutans or Prevotella intermedia. And these are both common mouth bacteria that cause dental decay, which is why you brush your teeth, to get rid of those bacteria. But I brushed my teeth this morning. But the thing is, they're all over the inside of your mouth as well. They're all over the inside of the cells. But using phase contrast, we can see individual bacteria like that, which is kind of fun. Right, let me zoom back out to the full picture. So that, oops, too far. There we go. And I'll focus it so that we're actually focused on the cells themselves, and I'll end on that. As always, thanks go to Zeiss, who provide me this microscope to allow me to show you these wonderful things. Later in the week, I'm going to be trying to tear apart an RFID tag. It was suggested to me by somebody. How does that work? I have no idea. So I'm going to dismantle one. And then on Friday, we've got a bit of a treat because we're going back to looking at stuff under a scanning electron microscope, which is a very cool and funky piece of kit. And I'll be driving the electron microscope remotely. So do join me on Friday and on Wednesday for this. With that, that's all I've got to say for you today. So thanks for tuning in. Do retweet and let your friends know. Take care. Bye-bye.